And if you understand any of this stuff, you're better than I am. It says FE6J1-2 Fever Tube preamp board is the circuit schematic design imitation crew music fax X10D to be rational optimization, more stable performance than the original machine tube play 10% increase. This board uses a single 12-volt AC input. The circuit processing provides 6J1 tube needed positive and negative voltage and filament power supply voltage. Power works. An open power tube filament heating is started when the boost from the 0 voltage start boosting hot filament tube, etc. also happens to boost boosting finish. So this is the same as the guts rectification 8 times 470 microfarad. The capacitor filter very clean, good power supply system. Will not have a hum. The filament is 12 volt DC power supply. Need 2 filament tube is connected in series with a DC filament also in order to reduce the noise. And well, it doesn't get any better from there on. So, and there's absolutely no instructions on how to put this thing together. But on the actual circuit board over here, it is clearly marked the components where they go and so on. So we should be okay. This article from like 4 years ago or something like that, somebody built that thing and did a little article on it. And the board must have changed since then because they put different and he has a link to this DIY tube amp, so I downloaded it, but I have edited it now. Okay, so I've actually edited the schematic over here, and comes in 3 parts. And which was missing on the schematic, so I put that in, and I've renumbered rather the components according to what they were numbered as in the on the circuit board. So in any case, since we're here, it has a little barrel jack that the power comes in, and it goes into a switch which is actually ganged with the variable resistor potentiometer, which we'll see later on. And what they've actually got here is a half-wave rectifier using this diode here that actually provides, and there's a resistor there to avoid these 2 filaments. They're actually 6.3 volt filaments, but they put them in series so you can run it off 12 volts. So we've got 12 volts AC coming in. We've got a half-wave rectifier and a little capacitor here which actually filters it, and that's good enough for the filaments, I guess. Doesn't have to be full wave rectified. A little 2.2 ohm resistor over here. When you first turn it on, the filaments are cold, so they will draw a big spike of power, I guess, so that a resistor will stop that from happening. And it's got 2 LEDs which absolutely serve no purpose other than to light up the tubes from underneath, and they probably think it looks pretty or something like that. So that is what those are all about. Now this over here is a voltage doubler, and each one of those doubles the voltage, from 12 to I think it's 28 volts, and therefore the tube circuit is running on about 56 volts, and that is it's got 2 diodes. It's called a Greinacher voltage quadrupler. You can, if you want to know exactly how that works, you can actually Google it, and there is in Wikipedia there is an article on voltage doublers, and they will explain that over there. But basically, the the voltage is doubled here from 12 volts to about 24 or more volts, and it comes out on those two pins there. So that's the power supply. And then there is what they're calling a constant current source for plus 28 and minus 28 volts. So the voltage from the circuits coming in here, plus V and minus V, and then over here the it is adjusted to give a constant current voltage output, I guess. So this here comes back at 28 volts, plus 28 and minus 28 volts. So that is part of the power supply. And then the actual audio part is over here. It's got two jacks, right and left channel sort of thing, and goes through. This is the ganged potentiometer, so you adjust the output level with that, and goes through some capacitors, uh, resistor. Don't forget that valves are like JFETs or field effect transistors. They have a very high input impedance, so you can actually have quite a lot of resistance there, and it'll be just fine. And here we have these two stages for the left and the right channel. It feeds in the plus 28 volts at the top there and the minus 28 volts here at the bottom, and that makes that a common cathode amplifier, similar to a common emitter amplifier in with transistors. And the output then goes to another capacitor, and there's a kind of a load resistor there, 100K, so that's going to be output impedance on that thing. So it's really like a line out type of impedance, but they seem to indicate you could run a set of headphones off it, but I'm not quite sure. Certainly wouldn't be matching. Most headphones got 16 ohms or something like that. But in any case, there's two stages there for the left and the right, and that's basically what it is. So let's go and build the thing, and then afterwards we will test it. Now it's going to take a while to build this. Normally when I'm building stuff, I might decide to get some light on the thing. I might decide to fast forward it, but I'm not going to do that this time. I'm just going to build it, and you can watch along, or in the description there'll be a timing diagram where the things are, the introduction and the building and so on, and the testing section. You can fast forward right to the testing section if you want to bypass it, because this is most likely going to be a little bit of a lengthy experience. Although if I'm doubling up, like if I am soldering up, because everything is doubled up, if I've soldered up one, I might still fast forward the second one or something like that. We'll see how things go. Anyway, so let's get started. Now, as I said, on here is going to be a tube socket, and you might notice it goes like this in there. But in any case, to make a long story short, there's that little LED is over here, and it goes through in the hole of that socket. So, and then of course the tube is made from glass, so it'll actually light up the glass. I think it's kind of like a bluish color or something. Let me have a look here. I've got the this side is supposed to be positive, and that side is negative. Yeah, it's like the blue LED. kind of looks white on the camera because the camera is overly sensitive to that kind of light. So I might put those in first. There's the second one. The second one is over here. Now the long leads on these LEDs is the positive side, and it is marked over here as positive over there. So we can actually put those in. Oops, stuck to my finger. Put those in over there, like so. I'm going to splay the legs out a little bit so it's not going to drop out. So I can turn it over like so. And now I can get the soldering iron heated up. Let's use this. Okay. Now when you're soldering through-hole components, you always bring the solder to the soldering iron. These are all through-hole components. But with surface mount components, this is no longer true. That's what I always, in the old days, when I went to college, there was no surface mount components yet. Like in 1980 is last year that I went. Although I did some more studies with computer programming. That was 81 and so on. Okay. Take care of those two. All right. Now another thing that I have already done, on this little circuit board over here, there was a trace. This is the power coming in from the jack here, and then it goes to the switch, and it comes back over here, and it goes into the rest of the circuit. But the little trace that skips this trace over here was actually very thin, and the rest of the traces are fat like those, and I didn't like that looks of that, so I put a little piece of wire. These are actually vias, but I put a little piece of wire in there to make sure that it doesn't have any too much resistance. Now I don't know why that was done. I don't know if it's some sort of crude form of circuit protection or something, but I don't think so because it's got this 2.2 ohm resistor there. I don't know. I didn't like the looks of it, so that's what I did. Okay, so we got these two LEDs mounted, which means we can really put these sockets in now. I'm going to use the thicker solder for that because these are big holes. Finger underneath. I'm going to tack one or two pins in this one here, opposite to it. Done. Okay, that's done. And now I can let go and I can solder in the rest of these pins. So the solder has a rosin cord solder, so I don't actually have to put flux on there. This one is bent that pin over to hold it, but it's encroaching on the other two holes there. I don't want it to do that. Now let's have a look. If I can snip off a little bit of that excess. Very good. Yep, 1 microfarad. Pretty small. They are 1 microfarad. So you can see that marked on there is 1 microfarad. And this is 1 microfarad. And there should be some more. Here it is, 1 microfarad and 1 microfarad. Yep, that's the only ones that are there. Okay. Use my thinner solders for these little ones. Right. Okay. The little capacitors done. Now we're going to do resistors. I think I'll just poke them all in there just in case before I start soldering them. Right, so let me have a look. No, I don't like the looks of that joint over here. Better. On pliers. Good that there's not a solder bridge there. No, that's good. All right. Now we've got a bunch of diodes here. 1N407. Little lines are marked on there for the cathodes or anodes or whatever they're called. One. Now this flush. Diodes done. Now I think we'll do the transistors. I'm doing the capacitors last because they are, this is a big resistor that can go into. This is the one that's in series with the filaments. I'm doing the capacitors last because they're the tallest, and you don't want to have to fumble around them to get smaller components flush with the board. Okay, yeah, 4 transistors. What are these things? B647. We know what they are, but haven't looked up the data sheet or anything. These transistors are only used for the power supply. They're not used for amplification or anything. In fact, there's no other amplification in here other than what the valves or tubes are producing. If you wanted to drive a speaker with a circuit like this, you would have to have another layer of amplification there, and usually with valves you would have to use a audio transformer because valves don't have a low output impedance. So to match the low impedance of the speakers, which is usually 8 ohms. So therefore the output of this is more suited, like to put a microphone on the input and put the output into the line in on a audio amplifier or something like that. Right. The inrush resistor, or whatever you would call that. Now, let me see. I'm going to use a different soldering iron for the transistors because they are small legs close together. I've got a smaller soldering iron here, finer tip on it. I need to turn the heat up a bit, this bit. Soldering up one leg first, and then I'll double check that they're in properly. Yeah, I see. Yeah, they're good. Alright, well, I can already snip off these legs so I have better access to the other ones. It's nice to have a variety of soldering irons. I've got 4 stations here with different tips in them, so I can just quickly grab them without having to change them. But I know that not everyone has that. Flux on there, but I just want to make sure that there's no accidental solder bridges there. That looks good. All right, so now I think we can get to the capacitors. So all the capacitors are the same. They're all marked 470, but I got one here that's smaller and it says 680. But on the board here and on the circuit it was marked as 470. But it's like a filter capacitor, so I guess the bigger the merrier. Put that one in first. And underneath it says that's got 12.6 volts across it. Got a couple of test points there, so after you finish the circuit, before putting the valves in there, you can test the voltages to make sure everything is correct. The negative side goes where they got those marked. This is the little barrel jack. I've also left some holes in case you have a transformer by itself, and you can solder them into these little holes here. But I happen to went to my junk box and I found suitable a little power supply. It actually came from a light marked marked Coleman, 12 volts AC, 400 milliamps. I don't know if this one has enough power, because it said 800 milliamps on the thing, but we'll try it. But I also have a transformer that can do 2 amps, so if worst comes to worst, I can use that. So we'll keep our fingers crossed. Wait a minute. There's yeah, 12 volts, 400 milliamps, 9 watts. Might not be enough. We know that filaments will consume about 2 watts. Oh, we'll have to see. All right. Now, only things remaining is to undo this board. See if I can put them in this way. This is that little ganged potentiometer. So two potentiometers and a switch. I have to tack this one on one pin or something. The switch pin. Yeah, so it will hang in there. Holes are way big for those pins on the switch. Maybe they have different wires or switches. Maybe one of the switches has larger pins on it, so they make the holes bigger. Okay, that's the potentiometer done. You click on off, and now it has jacks, RCA jacks. I have to do one at a time. Oh, they've got little tangs on there. Still, it's not holding it too well. The holes are too big. Okay. Well, in all intents and purposes, that should be done. Okay, so we're ready to start testing this thing. So I have this little power supply that used to be for some sort of light or something that is no longer with us. But this thing only has 400 milliamps capability. And I've already measured that it is very close to 400 milliamps when it is idling. And I did plug the power supply in for a little while already and monitor its temperature. It does get a bit warm, but it doesn't seem to be overly so. However, I think that at the amount of this drawing, it is pulling the voltage down a little bit. And I've got some more powerful power supplies coming that I've ordered, but in any case, we'll try it with this one. So I can turn it on. And as you can see, the blue LEDs come on, and you can just see the glowing of the little filaments in there. So everything there is working. Now I'm going to prop it up on this little container here. I'm going to put it like this so that we can home in on it. Now the first thing they want you to do is to double check that the voltages are there. So, and I've marked it on the board here, and this is supposed to be 12.6 volts, but we're only getting 11.4. It's sort of in workable, but I don't know if it works better at 12.6 volts or not. But in any case, that's because the little power supply, you know, is only output 400 milliamps, and it's probably drawing the voltage down a bit. However, these ones here need to be at least plus and minus 28 volts. Now, I guess it's the other way around. We're actually getting more than 28, so the voltage doubling circuit is working well. We got 32 volts, and we got 31.68 volts on this one. So they are actually a little higher than they need to be, but that's good. I have put some little test points, soldered them on there, on the inputs and outputs, so that we can have a look on the oscilloscope and so on, hooking things up. So that's what we'll do next. I'll get that set up and I'll be with you guys soon. Okay, time for testing. I've got the thing hooked up to my little device here, like I showed you before. There's input on just on the one channel here, and I've got the output going to my oscilloscope. I'm getting an amplification factor right now. If you look at the figures over here, I've got 28 millivolts coming in, and I've got 218 millivolts coming out, and it seems to be consistent. I have tried it right at 1.1 volts in, and it seems to be giving me the similar amplification factor. And this is a nice thing about these valve amplifiers, I guess. You can really drive them hard, or you can drive them low, and it seems to be able to handle that. It doesn't distort or nothing by the looks of it. In any case, the little control on there, as you can see, you can go from nothing to maximum. Now, obviously, you can feed in a audio signal there and get an audio signal out. And some people say they've been using them with headphones, and it works well. I, however, I'm more interested in using this with this old microphone. This is a pure highball, and was bought from Radio Shack. Oh, I don't know, it must be at least 40 years ago. And the thing is that this is made for a proper audio amplifier, not just to be fed into a PC. So when I feed the output of this into the PC, I am not getting enough output from the microphone or input from the microphone to actually use it. So I'm going to feed it into this little preamplifier, and I'm going to put the output into the PC, and I will record my voice with it, and we can see what it sounds like. So let me do this. I'll just hold it for a sec.
Okay, so I am now talking on the eyeball microphone that's going to the little preamp over here. And as you can see on the oscilloscope, that I've got the input set to 5 millivolt per division, and the output is actually set at 20 millivolts per division, and the output is higher than the input, so it is it's about 8 times higher than what the input is, and that seems to do a good job on the PC. I've got it fed into the PC microphone input port, and you can probably hear it. I don't know what it sounds like yet until I play it back, but I presume that it will be okay since the microphone is good anyway. So that is it for this particular test. I'll now go back to my normal microphone.
Okay, back to my normal microphone now. And in any case, it's been an interesting little project. And I think one takeaway from it is that these valves will actually not create as many harmonics as what transistors do when you drive them hard, overdrive them. And in fact, this particular circuit here is actually very resilient because I have driven it right up to like 1.2 volts input, and the output is still, even with the maximum amplification knob set full, the output is still very nicely shaped, no distortion at all that I can see. So that is one thing, I guess, with valve amplifiers, with the broad wide range of voltages that they can deal with. In any case, that's all I've got. It's been an interesting project. I received the second one just while I was working with this in the mail from Amazon. This is this particular one with the green PCB came from AliExpress. This one I bought comes in a pouch, with components. The only difference is that the PCB, which is exactly the same, is actually blue instead of green. And I might build the second one as well. Might be useful. I've also ordered some little cases for them. Make little cases for them. This one's a clear plastic one, but if you don't want it to be clear, I guess you can paint it with some spray paint, and goes like that. And then you have a little box for it. Since I think it is useful, so I might I'll put them in this little box. And another thing that I got is a better power supply. This one here can handle 1500 milliamps instead of only 400 that for the one that I'm using. So that should give the filaments a proper 6 volts to work with, and I'll have a look at that. Might even mean that it has a little bit better amplification, but it works with the little one as well, even at a lower voltage, so it should be okay. Anyway, that's all I've got for now. It's been an interesting little project, and let me know if there's anything else you want to see, and I will ask you to like and subscribe and hit the bell button or whatever you can do. Put some comments, and then I will see you guys later when I got another little project. Bye bye.